Today we're going to look at different landforms that we can find near the coast. Now the first landform that we're going to talk about is cliffs and wave-cut platforms. Now cliffs are sloping or steep rocks with different profiles, and these profiles depend on the topography and the geology. Now, if you don't know what topography and geology is, topography kind of describes the surface features of a region. So this is like the mountains, the valleys, and the plains, while geology studies the Earth's composition, structure, and the processes that create these landforms. Now, the geology and wave attack at the base of the cliff also affect the angle of the cliff's face. Now, low energy waves cause less damage than high energy waves. Like we spoke about in our previous lesson, high energy waves are usually destructive and low energy waves are constructive. Now, many cliffs have a neck point around the high water mark called a wave-cut notch, which is where the wave has undercut the rock. Now, through abrasion, corrosion, and hydraulic action, this wave neck point further extends the notches back into the cliff. Now, as this undercutting continues, the cliff above becomes unstable, and eventually it collapses piece by piece. The backwash of the wave then carries away the eroded material, leaving behind a wave-cut platform. This process will then repeat itself, and the cliff will continue to retreat, leading to a coastal retreat. Now, the processes of abrasion, corrosion, and hydraulic action was described in the previous lesson, but let's quickly go through them again. So we know that hydraulic action is the physical impact of the wave onto the cliff face. It's an erosion process where the force of the flowing water pushes air into the cracks and the joints in the rocks, causing repeated pressure changes that weaken the breakdown of the rock over time. Whereas abrasion is when the wave uses materials or substrates like rocks, shells, or whatever is in the ocean, and it holds these materials into the cliff face. These materials will then break down the cliff face piece by piece. So we can define abrasion as a type of erosion where rocks and sediments grind against each other, wearing away surfaces through friction. And then corrosion is because of the pH of the water. It's a chemical reaction where the water chemically breaks down the cliff face. Next, we have headlands and bays. Now, a headland kind of projects out to the sea. It has a cliff along its sides and is usually longer than it's wide. It has a geology of resistant rock. We'll look at why that's important in just a bit, whereas bays are a wide open entrance from the sea. They have a rough semicircular shape extending into the coastline, and the land that is usually lower than the headland surrounding it. Now, a bay may or may not have a beach. Let's look at the formation of headlands and bays. Now, if we have a piece of coastline that lays next to the water, this coastline might have alternating bands of resistant or hard and less resistant or soft rock running perpendicular to the oncoming waves. Now, this we call a discordant coastline. Now, initially, less resistant rock like clay is eroded back, forming a bay. The more resistant rock, like limestone, is left protruding out to the sea as a headland and can usually also be eroded just like a cliff is being eroded. Now, here we can see a headland that was formed, and here we can see a bay that has formed, and this bay does have a beach. Next, we're going to have a look at the formation of caves, arches, and stacks. So here's an example of a cave, an arch, and a stack. Now, usually wave speed will reduce as they near the shoreline. The angle of the wave will change and the crest will become parallel to the coast. This is known as a wave refraction. Now, because of this refraction, the headland erosive effect is concentrated on all sides of the headland, meaning that if there is a crack or an opening on the headland, the hydraulic action as well as abrasion and corrosion can take advantage of this weakness in the headland. So as the crack begins to widen, erosion will act to form a cave. The cave will become larger and eventually break through the headland to form an arch. So due to the weathering from above and erosion from below, the arch's foundation continues getting thinner and wider. Eventually, the roof of the arch will collapse, leaving behind an isolated column of rock called a stack. Now the stack is undercut at the base by wave action and subaerial weathering from above until it will collapse, and this will form a stump. Okay, let's talk about depositional landforms like beaches. Now, beaches form in sheltered places like bays. Now, the constructive wave action will cause deposition, with the swash being stronger than the backwash. So remember from our previous lesson, we learned that constructive waves have a stronger swash, meaning a forward movement, and a weaker backwash, which is the retracting or backward movement. Now, this forward movement will deposit usually sand and other materials onto the shoreline, creating a beach. Now, typical beach formation takes place during the calmest summer months. Strong winds can occasionally carry sand from offshore bars onto the shore as well. Now, blown sand near the beach's backshore can then also form sand dunes. We'll get into more detail about sand dunes later. We then get something called a spit. And a spit is an expanse of sand or shingle that stretches from the shore out to the sea. Now, this occurs when there's a change in the shape of the coastline. So a river mouth stops a spit forming across an estuary specifically. Now, spit may or may not have a hooked end, like the example shown, and depending on the wind and currents, this will either form or not. Okay, let's look at how a spit is formed. Now, the process that's involved in this is longshore drift that we did in the previous chapter. Now, we know that waves will come in at a certain angle to the coastline. Now, the wash, meaning the forward movement, would be at a specific angle, and the backwash would be at a right angle to the shoreline. Now, this will basically move sediment and materials down the coastline, and it will continue indefinitely unless the coastline changes direction. Here, a shallow sheltered area will allow for sediment to be deposited. Now, more deposition happens as a result of the higher friction of this lower, shallower area. Eventually, a spit will slowly build up to sea level and extend in length. If the wind changes direction, then the wave pattern will alter and result in a hooked end, like the previous example. The area behind the spit will become sheltered, and silt can be deposited here to form salt marshes or mud flats. Now, if the spit continues to grow across a bay and then joins two headlands together, it's called a bar. So a bar of sand is formed, called a sandbar. Now, sandbars can also form offshore due to the action of breaking waves from a beach. Now, the area that is separated from the ocean is then called a lagoon. We also get something called a barrier island, which is kind of like a bar, but it forms parallel to the coast, and the main difference between a bar and this barrier island is that the bar joins two headlands, whereas the barrier island is open at either one or both ends, kind of like in the picture shown. Lastly, a spit can also form a tombolo. Now, tombolo is formed when a spit joins the mainland to an island. Chesil Beach in Dorset is a tombolo, as the mainland is joined to the island of Portland. Another example is shown in the picture above. You can see how there's a bridge of sand or beach between the mainland and the island. The final coastal landform that we're going to have a look at is sand dunes, and they are a dynamic environment with changes occurring very quickly. Now, sandy beaches are usually backed by sand dunes due to strong onshore winds, which transport dried out exposed sand. Now, these sand grains are trapped and deposited against an obstacle, usually rubbish, rocks, or driftwood, to form dunes. Now, the dune ridges move inland due to onshore winds, pushing the seaward side to the leeward side. It is the interaction of winds and vegetation that helps to form sand dunes. Okay, so we know that sand dunes are formed because wind-blown sand is deposited against an obstruction. Now, as more sand particles are caught, the dunes will grow in size and form rows at right angles to the prevailing wind. Now, this process is called succession. Vegetation will eventually colonize and fix the ridges to the dunes. This is because vegetation has roots that can keep the sand in place and keep them from blowing away. Now, the first plants to arrive on these dunes are called pioneer species, and they have to cope with the salinity of the ocean, the lack of moisture because the sand drains water really quickly, the wind, the temporary submergence by wind-blown sand, and then also rising sea levels. Now, we get different types of dunes that are formed by succession. The first type of dune is an embryo dune. Now, the deposition starts when the debris or rubbish traps the wind-blown dried sand. The pioneer species like limegrass and sea couch grass will begin to colonize. There's a little soil content and high pH levels, meaning an alkaline pH level on this dune. The embryo dunes are very fragile and reach a maximum height of about 1 meter. Then we get fore dunes. The embryo dunes will give some protection against the prevailing wind for the fore dunes. This allows other species of plants to grow, like marram grass. Now, marram grass begins to stabilize the dunes with its root system. These plants add organic matter to the dunes, making the dunes more hospitable for plants that later grow. So now a microclimate forms in the dune slack, and this fore dune can grow up to a height of 5 meters. We then get yellow dunes. These are initially yellow but darken as organic material adds humus to the soil. Now remember, for those of you that don't know what humus is, it's dead organic material. Now, marram grass will dominate the vegetation, but more delicate flowering plants and insects are found in the dune slacks. 20% of the dune will be exposed, down from 80% in the previous one. Height does not exceed 8 meters for these yellow dunes. We then get grey dunes. Now they're the more stable with less than 10% of exposed sand and have a good range of biodiversity, meaning that there's a lot of different species that can be found on these grey dunes. The soil acidity and water content will increase as more humus is added to the dune. Shrubs and bushes will begin to appear. Now a height of between 8 and 10 meters can be expected for this type of dune. Lastly, we get mature dunes. So as the name suggests, these are the oldest and most stable of dunes. They are found several hundred meters or more from the shoreline. The soil can support a variety of flora, meaning plants, and fauna, meaning animals and insects, such as oak trees and alders, which is called climax vegetation. This is the final stage in succession, which is known as the climax community stage.